Hello, my dear students. Myself S. Devi, Assistant Professor, Department of Artificial Intelligence and Data Science, Rogini College of Engineering and Technology. I am going to teach the subject Operating System and Cloud Basics. Today we are going to discuss about DMA. DMA is nothing but it is direct memory access. First we will see the definition of the direct memory access. Direct memory access is a method that allow IO devices to transfer data to and from main memory without the direct involvement of the CPU. A special hardware component called DMA controller that manages this transfer by freeing up the CPU to perform other tasks. Instead of the CPU managing every byte of data between devices and memory, a DMA controller handles the transfer, allowing the CPU to focus on other tasks. This improves the efficiency of the system as well as reduce the CPU load during the IO operation. For example, this driver, graphical card, network card, sound card, all these are the IO devices which can access the main memory directly without the intervention of the CPU. Now we can see why DMA is needed. That is, normally when a device needs to transfer data, the device interrupts the CPU and the CPU reads or writes each byte of word from or to the devices, which wastes the CPU times. So to perform this transfer data between memory and the IO devices, the DMA controller that needs the buses to perform these operations, the DMA controller that requires the buses from the CPU. The various buses are address bus, data bus, control bus and internal bus. That is, the address bus carries the memory address where the data will be read from or returned to. The data bus transfer the actual data between the memory and the IO device. The third one is the control bus. It sends control signals like DMA request, acknowledgement and interrupt signals. And the last one is the internal bus that connects the components with the DMA controller for the coordination. We will see what are the steps involved in bus request. The DMA controller sends a bus request to the CPU. The CPU responds with a bus grant temporarily relinquish control. The DMA controller becomes the bus master, handling the transfer independently. Once completed, it sends an interrupt to notify the CPU about the completion of transfer. The components that are present in performing the DMA is DMA controller that manages the transfer process, and there are three registers: address register, word count register and control register. The address register that contains the address of the specific memory location, and the word counter register, it indicates how much data to be transferred. Control register, it defines the transfer mode and direction. And this is the general diagram for the direct memory access. The components that are present in the direct memory access is CPU, DMA controller, the IO devices, the memory and the buses. The steps involved in the transfer is: first is initialization. The CPU set up the DMA controller with the memory address, data size and the direction of the transfer. The next one is transfer. The DMA controller takes control of all the system bus and moves the data between the devices and the memory. The last one is completion. Once the data transfer is completed, the DMA controller sends an interrupt to the CPU signaling about the completion of data transfer to the CPU. The next one is the main diagram, that is the various steps involved in transferring the data. That is, the first one is the device driver is told to transfer this data to buffer at address X. The second step involved is the device driver tells the disk controller to transfer C byte from disk to buffer at address X. The third step is the disk controller initialize DMA transfer. The fourth step is the disk controller sends each byte to DMA controller. The fifth step is the DMA controller transfers byte to buffer X, increasing memory address and decreasing C until C is equal to 0. These process 2, 3, 4 will be repeated until C becomes 0. When C becomes 0, DMA interrupts CPU to signal transfer completion. We will see about the advantage and disadvantage of the direct memory access. The advantage is reduce CPU overload. The CPU is free to perform other tasks. Next one is fast data transfer. Fast data transfer, it is especially for the large block of data. The third one is improved multitasking. That means CPU can handle other process while DMA operation. Last one is lower latency. It is ideal for real-time and multimedia application. Next we will see the disadvantage. The disadvantage is cache coherence issues. DMA can bypass CPU cache leading to data mismatches. Next one is system complexity. It requires extra hardware and careful setup. The bus condensation. The DMA and CPU may complete for the system bus, lowering the performance. The fourth one is higher cost. Adding to the cost due to additional controller hardware, it increases the cost. Limited CPU control. The CPU has less control during the DMA transfer. The last one is interrupt overhead. The DMA still generates interrupt which can affect system speed.